Welcome friends. So we are discussing module 4 of network theory. This session we shall mainly discuss our first theorem, which is superposition theorem. Now the philosophy of superposition theorem revolves around that. Suppose you have a network with multiple sources, with multiple sources, just like in figure 12 we have two sources. This is source number 1, voltage source, and this is source number 2, that is current source. So the superposition theorem will only work for those networks who have the two source, minimum two source. So a network with one source, we cannot apply superposition theorem. So we have a voltage source as a source number 1, and we have a current source number 2. Now let us say for this diagram, let us say a current flowing through this R, resistance R is I. Let us say this current is I flowing. Now step by step, now the superposition principle or the philosophy of superposition principle is that you need to consider one source at a time. You need to consider one source at a time. So let us say first we consider source number 1. We consider source number 1. We have not considered source number 2, that is why it is open circuited. So as the source number 1 is only present, then that voltage source as a source number 1 with that will inject some current, definitely inject some current, and let us say some part of it or full part of it, we don't know, or some part of it or full part of it will flow through this R, will flow through this N, and let us say that current is I1. Let us say that current is I1. And we will follow the similar procedure for the second source. Now we are considering source number 2 as an active source, and we have removed or we have not considered the source number 1 by short circuiting it. So definitely, as this current source is present as an active source, so it will inject some current. And that current, maybe part of it or full amount of it will flow through that resistance R. Let us say that current is I2. So in this way, for n number of sources, this process will be repeated. So at a time, one source will be considered, other source should be deactivated. So in each step, when you consider any particular source, you need to consider its response. Just for an example with this, for this example, so if we consider the voltage source, so its response is I1, as it can be seen in the middle figure. And when the current source is active source, then its response is I2. So the superposition theorem tells you that this individual response, if you sum them, then it will be the total response. So the total response is equal to the summation of individual responses. So I must be equal to I1 plus I2. So this is the statement of the superposition theorem. It is given in split manner. So in the first point, it is written that the superposition theorem will be applicable for which type of network? That is, it will be applicable for linear network, active network, and bilateral network. These three are very important terms, which is the definition of which is already discussed in the module 1. Now that content must be two or more energy sources. So with that we can clearly understand that with one source we cannot apply superposition theorem. So we must have minimum two number of energy sources. That energy sources either can be voltage source or can be a current source. So that part is okay. So we must have a two voltage source or two current source maybe minimum, and it will be applicable for a linear active bilateral network. Now what we are trying to find, the current flowing through any resistance, current flowing through any resistance or potential drop across any resistance, that will also be true. So how can it be found? How can it be found that to have the response or result for individual energy source kept on at a time, that means you need to consider one source at a time, keeping remaining all other sources deactivated. That means when you are considering one particular source, at that point of time other sources should be deactivated. Just like for the first case we are considering source number 1, we are deactivating source number 2. Similarly, when you are considering source number 2, we are deactivating source number 1. So in this way, when one particular source is considered, then other sources should be deactivated or should not be considered. Then what will be the result? Total response, that is the I, that is total response, is the summation of all individual responses. That means what we have just mentioned, that is individual response is I1 for the voltage source active and I2 for the current source active. So if you add them, it will be the total response. That should be I is equal to I1 plus I2. And final point, how you can make sources deactivated? Voltage sources are short circuited. Just it is done in this case because source 1 was a voltage source, so that is why it is short circuited. And current sources are open circuited. Current sources are open circuited. Okay, so that is the statement of the theorem. So it is purposefully written in this manner to make you understand. So first point is all about the network for which we can apply superposition theorem. First of all, it must be a linear active bilateral network. Then that energy or that network must have minimum two energy sources. Okay, two or more, minimum two it must have. Now current flowing through, how can it be found? That you need to consider one source at a time. It is written in third point, one source at a time, but at that particular time you must deactivate all other remaining sources. Then total response is the summation of individual responses just mentioned here. And lastly, how you deactivate voltage source? If it is a voltage source, it must be short circuited, and if it is a current source, it must be open circuited. So that is the statement for superposition theorem. So let us quickly solve one problem with this philosophy. Let us consider figure 13. Let us consider figure 13 where it is asked that voltage across 20 ohm resistor. So this is 20 ohm resistor. You need to find out voltage across 20 ohm resistor, this resistor. So we have four sources. One voltage source 16 volt. The second one is 3 ampere current source. Third one is 10 volt voltage source, and fourth one is 1.5 ampere current source. So we have four energy sources present. So we need to evaluate what will be the voltage across this 20 ohm resistor. So in order to find out the voltage across 20 ohm resistor, you need to first calculate what is the current flowing through this 20 ohm resistor. So once you have got the current flowing through, So you just multiply that current into 20, you will get the voltage across 20 ohm resistor. So current flowing through the resistance is the main. So once you got current, you will get the voltage drop. So we have 4 voltage sources. So according to superposition theorem, you need to consider one voltage source at a time, or rather one energy source at a time. You must keep other sources deactivated. So let us try to understand how we can make one source at a time, or how can you utilize one source at a time. Let us consider first 16-volt source is on. 16-volt source is on, other sources are off, right? Other sources are off. So let us draw the circuit diagram again. So we have a 16-volt source, right? This is 16-volt source. Then we have a 20 ohm resistor, right? Okay. Now, as far as this 3 ampere and 1.5 ampere are concerned, how they can be deactivated? They must be open circuited. So it is simply open circuited, right? So this must be open circuited to make these sources are deactivated, right? And this 10-volt source should be kept shorted. So this 10-volt source is simply shorted like this, and we have 80 ohm resistance. So basically, so what we have done actually here is that, so when you consider this 3 ampere current source, when you are considering this 3 ampere current source, you are making open circuiting. You are making open circuiting, right? To make it deactivated. Once you have 1.4 ampere current source, then you are making again open circuiting to make it deactivate, right? Now once you have 10-volt voltage source, you are making it short circuited. So you are making it is short circuited, right? So you are making it short circuiting. So basically, if you closely understand, or if you can analyze, it is nothing but a very simple circuit, that is a 16-volt source is connected with 20 ohm and 80 ohm in series. So one current should be flowing I, and that current must be flowing through the 80 ohm resistor, because this open circuit path does not provide any current to flow. So no current should be flowing through this open circuited path. So entire current will be flowing through this path. So it is a simply this 16-volt source in series with 20 ohm and 80 ohm respectively. So if we consider this current as I1, right? Let us say this current is I1 for the case number 1. So I1 is nothing but 16 by 20 plus 80, which is equal to 0.16 ampere. So voltage drop across 20 ohm resistors, that will be equal to 20 into 0.16, which is equal to 20 into 0.16. Let me make more space. So V1, that will be equal to 0.16 into 20. So it will be 3.2 volt. 3.2 volt, right? So what should be the polarity? Polarity should be, left hand side should be plus, right hand side should be minus. This should be the polarity. So the voltage across 20 ohm resistors is 3.2 volt when 16 volt source is only present. 16 volt source is only present, right? Now let us consider 3 ampere current source, right? Let us consider now 3 ampere current source. So let me draw the second case. 3 ampere current source is on. Other sources are off, right? Other sources are off. So now if you consider, now if you can draw the circuit diagram. So this will be my 3 ampere current source. So you must deactivate other sources. So we have 20 ohm resistance here. Now this voltage source must be short circuited. Voltage source should also be short circuited, and we have 80 ohm resistance here, and this 1.5 ampere current source is also short circuited. Sorry, no, not short circuited, it is open circuited. So what we have done here is actually we have deactivated. So we are now considering only 3 ampere current source. So we are making deactivating 16 volt source by making it short circuit. We are also shorting the the 10 volt source by making it short circuiting, and we are also deactivating 1.5 ampere current source by making it open circuit. So now if you analyze this circuit, in the second condition, this 3 ampere current source will get two different paths, one along this, another along this. So let us say if this current is I2, so we can use, or we can write the value of I2 by using the current division rule, that is total current, which is 3, into resistance of the other branch, which is 80 ohm. So this should be 80 ohm, and divided by summation of all 2. So 80 plus 20. So it should be 240 by 100. So it will be 2.4 ampere. So if current flowing through the 20 ohm resistance is 2.4 ampere, so what will be the voltage drop? That is V2. The V2 will be 2.4 into 20, that is equal to 48 volt. Now what should be the polarity? Now for this case, for 3 ampere case, the polarity should be like this. The right hand side is plus, left hand side is minus, because current is flowing from right hand side to left hand side. It is very important. So when you add at the end, when you add all the responses, these polarities should come in picture. So this is the 3 ampere current source. This is the solution for 3 ampere current source. So as we can understand here, you see this is the circuit diagram for 16 volt source is on. So this is the circuit diagram, and we have evaluated our voltage is 3.2 volt, and now this we have solved, that is 3 ampere source is on. It should be the equivalent circuit. So we have evaluated, our voltage is 48 volt, right? These two we have solved. Now we have third source as 10 volt. Now we have our third sources is 10 volt. So now we will say our third condition, 10 volt source is on others are off, right? We now considering third thing. So we have 10 volt source, right? This is our 10 volt source. This is our 10 volt source. Now we have 20 ohm resistor. Then you must open circuit to make this is open, the second source is deactivated. You must make short circuit to make the first source deactivated, and you have 80 ohm resistor, and then open circuiting 1.5 ampere current source. Let me recap. We have a 10 volt source as a third source. So we have 16 volt source as our first source. So we are making it shorting to make it deactivated. Then we have our second source, as it is 3 ampere current source. We are making it open circuiting. And we have this 1.5 ampere current source deactivated, so by making it open circuiting. So only 10 volt source is active alone. So if you carefully analyze this circuit, so again it is same thing. This 10 volt source is connected in series with 20 ohm resistance and 80 ohm resistance. So a current should be flowing in this direction. Let us say that current be I3. Let us say that current be I3. So this current cannot flow through this open circuited path, because through open circuited path no current can flow. So one current will be flowing through this 20 ohm resistor, that is I3. So that current will be coming back to this 80 ohm resistance. So 20 and 80 ohm resistance are connected in series. So I3 is effectively nothing but 10 by 20 plus 80, which is equal to 0.1 ampere, and V3 is nothing but 0.1 into 20 volt, which is equal to 2 volt, right, which is solved here. And the polarity is, right hand side is plus, left hand side is minus. So that is our third solution or third response when 10 volt source is on. Now lastly, when we consider our last case, our last source, when you consider our last source, that is 1.5 ampere current source. So let us say this is our 1.5 ampere current source. So this is fourth case when this when this 1.5 ampere, that is our remaining final source, 1.5 ampere source is on, remaining sources are off. So the equivalent circuit is like this. We have a 1.5 ampere current source. Then, so you must sorted the voltage source, which is actually equal to 10 volt source. So you must sort it. So then you have 20 ohm resistor. So again you will have a short circuit path. Here you have 80 ohm resistor. And finally you have your second current source or second source, which you must open circuiting. So if you analyze this, so what we have done here is that first we have made the first source, which is 16 volt source, shorted. Then we have second source, 3 ampere current source, we are making open. Then we have a second voltage source, that is 10 volt source, which we have made shorted. And finally we have considered only 1.5 ampere current source, and remaining two resistances are there, 20 ohm and 80 ohm registered. So now if you analyze this circuit, you can find that this 1.5 ampere current will be circulating through this loop, or rather mesh, because it is shorted. With respect to, if we can say this node is M and this node is N, okay, if we consider this node is M and this node is N, so with respect to M and N, this is a short circuited path, and another path is this, so with respect to short circuit path, so we have a 1.5 ampere current source. Then with respect to this, we have a short circuit path, and remaining we have a 100 ohm resistance connected, that means 20 and 80 across this terminal M and N, right? So across this terminal M and N, we have a 20 ohm resistance and 80 ohm resistance are connected in parallel. So basically it is a current division rule, as already explained. So when a resistance is short circuited like this, no current should be flowing. No current should be flowing through a resistance. So this resistance is effectively out, deactivated. So the entire current will be flowing through the short circuit path. This entire 1.5 ampere current should be flowing through the short circuit path. So if we consider this current as I4, so I4 here should be 0 ampere. So no current should be flowing. This is because 1.5 ampere current source is short circuited. So in this case we have V4 is equal to 0. So just to recap, when you consider 16 volt source, you have got V1 as 3.2 volt, polarity as shown here. This is the polarity. When you consider the second 3 ampere current source, your voltage appearing across is 48 volt, polarity is shown here. So third one, 10 volt source, your voltage is 2 volt, polarity as shown here, and this fourth one will be 0. So what will be the total response? It is the summation of all four according to the superposition theorem, V1, V2, V3, V4. Now V4 is 0, it is ruled out from the expression. Now V2 and V3, you see what is V2? Now V2 is this. V2 is 48 volt, right? And V3 is 2 volt. So these two, V2 and V3, are additive polarity because their polarity are same. So V2 plus V3, so these two should be added. 42, 48 and 2 volt should be added. And you see with respect to this, you see this 3.2 volt is subtractive one. Is 3.2 volt is a subtractive one, right? And this 3.2 volt, it is a subtractive one. So due to that reason, in the final expression it is written minus 3.2. So if you solve this, you will get the voltage across the 20 ohm resistance is 46.8 volt. Considering all the sources. So here polarity is important. polarity of the potential is important due to this reason. Polarity of potential drops is important. It's not that you simply add those three. It depends on the polarity. Additive polarities must be added and subtractive polarities must be subtracted to get the appropriate result. Okay. So we have 4 voltage sources present here. Sorry, not 4 voltage sources. We have 4 energy sources present here. 2 voltage source, 2 current source. We have considered one source at a time, keeping deactivated others. So we are getting responses individually. And when you get the complete response, we have done this loop for the four number of sources. Then with the individual responses, if we add them to get the final response. So the total voltage drop. So if you see, this is the mother diagram. If it is the if it is the circuit, so if it is the circuit, so total voltage drop across this 20 ohm resistance, what we have got, it is actually 46.8 volt, right? So this voltage drop is 46.8 volt. What should be the polarity? This is plus, this is minus. That is very important. So this is the answer. So with this we have explained the superposition theorem, principle of superposition theorem, and we have solved one problem on superposition theorem. It is very simple, that you should consider one source at a time, keeping other sources deactivated. So in this way, when you get the complete response, all the responses, then you must add them to get the total response. So with this, I am ending this part. So from the next part, we shall start the next very important theorem, which is called Thevenin's theorem. Thank you.